Hello everyone. Now we are getting started with our project, and this is a high level introduction for our project. What we are going to do, this is a data pipeline using Apache Airflow, and as we all know, Airflow is an open source data engineering workload uh, platform which we can schedule and run our data pipelines from task one. Just I will give you a high level overview. uh, let's say you have different tasks which needs to be performed in a sequence. When the task one is complete, then task two, then task three, and let's say in parallel we can run task four, and the output will then combine into task three, somewhat like that. This is just for an example. This kind of graph is called DAG. Direct acrylic graph. Direct acyclic graph. So Apache is an open source, so we will be using an Apache for our project, from where we will be getting our data from Amazon S3 bucket, and then in the end we'll be loading our transform data in S3 buckets. These you can say extraction of data on the first step, from where we are getting the data. This can be changed from your, let's say, from SQL server, some Azure storage, or some other storage, whatever it can be. And accordingly we need to modify our code which is written in Python. And in the end also, we are uploading our data to S3 back. But here we can, it depends on from business to business where you want your data to be displayed, and who are the consumers of your data and from where they are getting their data. This can also be, destination can be SQL and some other storage services also. So in between is our transformation logic, and these are the steps: the extraction, transformation, and then loading. So for the extraction we are getting Twitter data, and this data is sentiment data. This is not, you can say, we are not doing any analysis on that data. We are just getting familiar with Airflow and transformation logic in Python, and how we can get our data from Amazon. This is data pipeline, basic data pipeline. So we will be getting that data from Kaggle, and let's say we have uploaded that data onto our S3 bucket, and once uploaded we will get that data for the extraction. And this extraction, or getting the data from Amazon S3, will be done through a coding logic, and this data is then stored inside a Postgres SQL table to raw tweet data. After that, there is a block of our transformation logic, in which we will be running a transformation code in Python, and then we will be storing that extracted, or transformed data onto our another table, which is our desired tweets. And in the end we will be using a Python, again a logic, to get that data from our SQL table, in this case Postgres. These can also vary. You can use MySQL, or MS SQL also. This depends from case to case, and uploading that data back to our Amazon S3 in the CSV format. This is a basic overview of our data pipeline, how we are going to perform this. Thank you very much. Hello and welcome back. Now in this video we are going to install Airflow inside a Docker. What is Docker? Docker is created for the developers, so that everything is in container and image base. So whenever I create an image or container and put it on the internet, you can consume it as long as you have a Docker installed on your system. Irrespective of the operating system, it will work. So isn't that great? So let's get started. First of all, we need to download the Docker. I'm using Windows, that's why I will be selecting a Windows installation. So here we can download the Docker desktop. We have Intel chip for Mac, Apple chip, then AMD and ARM processor. I'm on AMD 64. The structure is 64-bit. For AMD and Intel, this works for both. So I have already downloaded it, so let's head back there. Sorry, not here. It's inside the downloads. Here, the Docker I have downloaded. Okay, so let it install. Before installing, let me show you Windows features. Turn Windows features on and off, and from here make sure to select Windows subsystem for Linux WSL and click OK. I have already done it, so I will cancel it. It's gonna take some time, so let me pause the video here for a bit. One another thing, before installing the Docker, go into the task manager and inside your processor, see the virtualization should be enabled. For me it is enabled, but it's by default disabled, which is not the case. Then you can go inside your BIOS and enable it from there. Okay, so I'm gonna pause the video here and we'll be back. So the Docker desktop is installed. Now I will log in using, oh not here, sorry, let me log in using GitHub. I have a lot. Okay, sign in. So let me put a code. Okay, I will authorize. Okay, so these are some steps you need to perform. For now I'm gonna skip this one, and we have our Docker running. Let me minimize it. and open a Visual Studio Code. And inside code, I will like to open a folder. Okay, I will open a folder I have already made inside C and Airflow Docker. Let me select it. And we already have a Docker Compose file inside. But for now, let me delete this file. Yes. And we are inside the folder. Go into the terminal. And here we need to run Docker versions to see if everything is fine. Yes. Now the next command, if these two commands work, then it means your Docker is working fine. That's fine. So our Docker is working. This is curl command is actually Linux based command, but sometimes it work on Windows too. This is gonna download the Docker version for us, Docker Compose file, sorry. No. So let me copy the Windows file here, or PowerShell command. And you see after the PowerShell the curl does not work because it's a Linux, but Windows do have a small functionality of curl also. Docker Compose is being downloaded for us. So we have celery executed, Postgres, everything inside the Docker Compose. So I'm not gonna change it for now, but if you don't need a celery executor, you can remove it from here, and also the Redis from here, celery broker and celery result backend. You can remove it here from also from the instance. And also the worker, and there is one other thing. Yes. So for now I'm gonna go with this one, this YAML file as it is. For that I'm gonna create directories by using make directory. This is also a Linux based command, but it works on PowerShell, and no, it's not working. Okay, fine, we will use this one, PowerShell command. So you see we have three directories created: DAX, logs, and plugins inside. This is actually curl and make directory is a Linux based commands. These are alternative PowerShell commands for Windows. Then we need to run this for Docker Compose up Airflow init. So we need to initiate the database for that, and it's running. It's gonna take some time. So for that, I'm gonna pause the video for a bit. So once you see Airflow init 1 exited with code 0, it means it's successful. So this is the most important part, Docker Compose up D. And D means in a detached mode in the background. So it's waiting. There is some kind of error, and I'm gonna allow this. So let's go into the Docker, and we have Airflow Docker, and let me start this one also from here. So it's started. It's pretty easy as compared to installing Airflow on locally without the Docker. So let me go into the browser, and 0.0.0.0 8080. Okay, this can't be reached. Localhost 8080. Why? Let me see what the error is. No, there is no error. Localhost 8080 will work for us because Airflow is running. Airflow, and password is also Airflow. Let's sign in, and we are inside our Airflow. Okay, go to hell. Sorry. So this is how you will install a Docker Airflow using Docker. It's pretty simple, much simpler than installing Airflow locally, because locally we have to first install WSL, then run the WSL commands, and so on and so forth, and also very easy to install packages. So we will see how we can install different packages inside our Docker. Sorry, inside the Docker Airflow instance or container we have created. So we have Docker Airflow, Redis, Postgres, Airflow. This is Airflow services, port 8080. So that's all for this video. Thank you very much. Bye bye. Hello, and welcome back. Now in this video we are going to see how we can add packages inside Python to work with the Airflow, because that is very necessary. We need different packages. So in order to do that, just create a new file with the name requirements.txt, and let's say we want to install matplotlib. Okay, and we have to see which version of matplotlib is currently. Matplotlib in Python for Python 3.12. Okay, we'll go into PyPy. Let me check the release history, and let me Let me get 3.9.0. Once the requirement is being done, let's create a new file with the name docker file. Okay, and open that file, and inside we will simply copy these, sorry, up till here, and currently our airflow is, let me check the version of my airflow. It is 2.10.4. 2.10.4. Okay, once we have done this, we are giving it from Apache Airflow, which we have created before. Copy, using the copy command, we are telling it to see the requirements.txt and then run these pip install. Once it's done, let me copy this command, docker build dot tag minus tag airflow latest and then latest. Sorry. Mm, oh, okay. These are two minuses, and it's gonna take some time. Field source cannot be empty. Sorry, why? Okay. We have to save that file. Hmm. Okay, there we are getting some error. Let me pause the video a bit. Why we are receiving any version for matplotlib? Let's me go into a user file, and I have seen that we need to install it globally. Then let me save it and run it. Mhm. Still an error. And I'm at the start of dependency. Okay. Double. Double. These are the errors, which is the typing mistake from me. Hopefully it will solve our problem. Let me pause the video. So we have removed the user, and here we also need to install globally. Just run it. Sorry. Hopefully it will solve the problem. We haven't saved the file. Okay. So it's gonna take some time. Now it's done. So make sure to set the user globally. No need for this. And here we have a typing mistake, and no need for the user. Here also double slash typing mistake. Hopefully by now it's taking some time. So let me pause the video for a bit. Here, one other thing to remember, I haven't specified version number, but you can specify if you want. It will install the maximum available version for us for the Python we have installed. So that's how you will install Matplotlib. I'm going to pause the video for now. There is one other step we need to do after that. So now it's done. Everything has been installed, and here we have Airflow latest. Just go into Docker Compose file and let's see where is Airflow image name. Let's first see in the Docker. Sorry, we have Airflow Docker. Okay, here just change the name and it's done. Just add, do not remove this minus sign, and add the new name here and save the Docker Compose file. Now after that, just go inside your folder and refresh the page, and our page is being refreshed, so everything is being built, and now the Matplotlib is inside our Airflow image. So that's all for this video. We will see how we will write a one DAG and see if the Matplotlib is there or not, but this is the video of another time, and we will write it later on. Thank you. Now, sorry, now everything is set up. We have set up a Docker, and inside Docker we have Airflow. Now we will be using Kaggle, and on Kaggle there is a dataset for 1.6 million tweets by Casanova. We will be using this dataset for this project, and it has these columns: target, IDs, date, flag, user, text. We will do a bit of ETL from in the form of columns which we require. That's all. Will not be going deep into what the data set is going to give us. So first of all, you have to create account on Kaggle. If you do not have, you can sign it with Google or create an account. It's pretty easy, straightforward. Other thing is you can download the zip file. So we are going to download the zip file, or we can use the Kaggle API, but for now, for the ease, we will be using a zip file, and then uploading that zip file inside our Amazon bucket. That's all. Okay, so to access S3, we need to do some things on our Amazon. So first go into IAM, and inside policies, let's create a policy, new policy to access our bucket through an API. Here you can see the JSON, or visually you can select the service S3 and filter the actions, and in resources let's access ARN for these actions. I will, for now I will click all, so we don't get any errors. That's why this is the JSON of this policy, or we can put our own policy in the JSON format, and then click next. We need to give a policy name. Let's see, bucket access. This will be the our policy name, and let's create that policy. So our first step is complete. We have created a policy in which we have given access to S3 bucket. Now we will go into users, and we need to attach that policy with that user. So currently you see we don't have any policies. Let's create add permission, and here I will click attach policy directly, and if you search you should have a bucket access policy which we have created, bucket access, and it's right there. Number 3, bucket access ticket. Click OK and add the permission. So once that's done, we have given access to this user which we have created before. Creating a user is very easy, you can do that easily. And inside, now we will create a API keys, and we can create that for that user. For now I have already created it, but it's very easy. Just copy the API access key and API access secret, because it won't be displayed again. So this code I have written for the testing only. Let's just search it using a Boto client. I will try to provide this code, and you see the file successfully uploaded, and we don't get it. So now I will give you a basic overview of our transformation logic of different steps in Python. We will be using Python for that. So for the extract function, the first step we will be doing, I will show you the code and explain it how we are doing the steps, but maybe will not be writing the code in real time, because to save the time. So for the extract function, first of all we will check whether the tweets table exists in the data. These are, you can say, a raw tweets table exist in the data. And also we will check there is another table for logic. Let's say I want this data pipeline to be scalable data pipeline. What does it mean by, I don't want each time when this data pipeline run, all my data will be downloaded from S3, and then it will be inserted inside the table. For that we have another table which is called S3 file data, and what is stored in this table, the timestamp of the loading of the data on Amazon S3 bucket. Let's say if I have loaded the data on 010825 and the time is 9:40 and our data pipeline runs after 24 hours. If there is change in this timestamp in any way, whether it's in minutes or in date, then the data will be downloaded and will be inserted inside our tables. But this will be incremental load, not all data will be inserted each time. The code will check whether the rows are which new rows are being inserted, and only that rows will be inserted inside our raw tweets table. So if yes, then it will check whether the records are present in tweets and S3 file data table, and if yes or no, connect to Amazon S3 and fetch the file metadata. This metadata is a timestamp in our case. We are not getting anything else, any metadata else. And if there is no table, then we will create the tweets table and will follow along. Then is the file last modified newer than the database record? This will be checked against S3 file data table inside our SQL, which is being created with the timestamp of S3. And if yes, then it will download the file, load the CSV content into data frame, filter out existing tweets from database, insert new data into tweets table in chunks. So here another step why we are using chunks. Chunks is like, let's say we have 1.6 million tweets, and as we know, the Apache process the data in memory, so we may not be able to insert the whole data at once. So we will split that data according to our hardware. Let's say we can handle the data up to 10,000 records at each time, so it will divide 1.6 million tweets into 10,000 of different buckets of 10,000, and then we'll insert one by one. So it will insert the file last modified into S3 file data for the file metadata, and it will log the inserted new tweets successfully. This is just a message at the end when it's done. And if the last modified is not newer than our database record, then it will simply end our extraction logic. This is for the extraction. Now let's say what we are going, or how the Python program logic works in transformation function. So here it will fetch the data from tweets table. Simply, it's already inserted during section. Is the fetch data frame empty? If there is no data inside our data frame, then it will, if yes, it will log no data into its table. This is just error handling, you can say. If there is data frame is not empty, then what it will do, it will assign headers to the data frame. We need to do that. Extract month, day and year from the date column, because it's in string and we know we need a proper date format to later consume it for the data scientist or machine learning or for the analysis. So it will format the data in mmddyyy format. Drop unnecessary columns which we do not require. Filter rows where user is required user. So this is our logic for transformation, that let's say I want tweets for Katy Perry, then it will only insert the tweets from Katy Perry, and we can define multiple users also. Check if required tweets table exists. If we have previously run this data engineering workload, then this table will exist definitely. Fetch existing tweet IDs from required tweets, filter out rows with existing tweet ID, insert new rows into required tweets in chunks. So here also we are using chunks, so we will not overwhelm our memory or processor. Uh, Also we are making this data pipeline incremental, not a bulk insert. Then log the inserted new rows into required suites, and in the end it will end. So this is for the transformation logic. Now in the end load function, we will be getting our data from tweets table, required tweets table, sorry, required tweets table, and then fetch data from required tweets table. Good. Is the fetch data frame empty? This is just error handling. If yes, no data found in required tweets table, and if no, then convert the data frame to CSV format. Connect to Amazon S3 using credentials. Upload the CSV to S3 bucket. Did the upload succeed? It will, our program will check. If yes, it will give us a message or that data successfully uploaded, or other if no, then the error loading message, and our pipeline will complete. So these are like different DAGs for extraction. So how it's happening, how our graph or direct acyclic graph will happen. This will be our first task. It will done this one, then it will move to the second one, and in the end it will move into the third one. So this is an overview of our project, what we are going to do. Thank you very much, hope you got. Now we will move forward. So one other thing is how you can get your keys. Let's search IAM and go into this IAM service authentication mechanism, and inside the users I have user Nasir035. You can create it, then create a policy for that. It's already mentioned. Click on this, and here you have access key, so we can create a new access key and revoke this one also for that user. Now we can delete the user. So I will not be able to access this key for now. It's only one time. Otherwise you will copy these values, your access key, secret key, and secret token, once you create your key. Let's click on the access key 2, and here let me select third party or application outside AWS. You can use the access to, and here you will create your access key, and it will give you the uh, access key token and access secret key. You can copy that values. That's all. Thank you. Now let's get started with the project. So in this phase, let me give you a basic overview of Amazon S3. And if we search S3, here we will have buckets. Let's go into the buckets, and I have one bucket, Airflow Basic 035. This is the name of the bucket, and here we have folder initial upload, and I have already uploaded my file here with the name. whatever the name is in CSV format. If we click it here, we have a complete URI, Airflow Basic, a bucket name, then our folder name, and then our file name. So let's head back now. And one thing also I would like to show you is the output folder. Here we have some files. Let's delete them. And this is the folder in which our all the files from our load function will come after the transformation and everything. So now this is empty. There is no folder now. So for to get started, let me open a Visual Studio Code. And in code, I already opened a project folder, but let's say if you don't have that, I have already opened it. Go into the files and click on open folder, and from here you can select your folder and select the folder and it will be uploaded. Also, I have started my Docker also. Let's say if it's been up and it's failed because our Docker is already up and running. Now we have to. So I have already created it. Let me show you the step. I'm inside Docker desktop. Just to show you, you don't need to do this step. Let me stop the Docker, which already not running. Now our container is stopped. So let's start our container docker dash compose up dash d in a detach mode, and it will start our container. It will take some time. In the meanwhile, we have our folders created in the previous steps, and I think everything is set up on your PC also. Here we have docker compose file, docker file, and requirements, which are the, you can say, packages, Python packages we require. And in docker file, these are the previous step already mentioned. So let's go inside a DAG and start writing our transformation logic. Let's click on the new file, and here I will name it etl.py. I will not be writing the code in real time because that will be a very time consuming. So first of all, let me get the imports, what we need to import, which packages we need to import. So we are importing Boto3. Boto3 is a package to connect with Amazon. We are using pandas for data frame and data processing. Then IO, this will generate a string for us in a loading process to our Amazon S3 bucket at the last step. Then the SQL Alchemy is used to connect with our Postgres database, which is also included inside our Docker container. Then a datetime function for the datetime. Let's get the extraction part. Here up till here. So this is our extraction function. which I have created. Let me explain it quickly. I already explained the logic of the function. So the name of the function check and extract data. This is the bucket name, S3 bucket name. Then S3 object key is your folder name with your file name. Then the DB engine, we will be creating an engine to connect with our Postgres database, and these are the values of our Postgres, which is also on the local host. So we are creating an engine. Then check and create table. This is inside our main function check and extract data. This will check whether the table exists or not, and if not, it will create the table. This will create a table S3 file data in which the metadata of the uh, file for S3 bucket will be stored, and these are the field ID, file last modified, created at, this is default now, this is locally, but we will be working with file last modified from this field. Then another folder for the another table from the tweets, in which we have id, tweet id, target, date, flag, username, text, created at also. Then the transformation logic with db engine.connect. I am not going to explain the Python how it's working, because this is not a Python project, you can say. So the table name is tweets, table exist. Here the boolean variable will be stored, and we will be writing or executing a query inside our SQL engine with the table name tweets. If the table exists, then it will count the total value of tweets, and also will count the file last modified, the like how many rows are there. If tweet count and file last modified count is greater than 0, then it will print the total number of tweets and file last modified. These are the number of rows which will be printed, and this property is important, or scalar. It will give us a scalar value, otherwise directly we cannot get it, said Python. Or if table does not exist, and if the tweet count is less than 0 or 0, then check and create table function will be executed, which is, sorry, check and create table, yes, this function will be executed and it will create the tables for us. Then here we will be connecting with our S3 bucket, which is, I have named a variable S3 client using Boto library, and here we will be giving values, required values to authenticate on Amazon. Service name, access key, secret access key. Don't worry, I will revoke these secret access ID and access keys. These are the values which you need to change according to your Amazon account. These two values you need to change, and also you need to change your bucket name and also the object key, the complete path of your file. So the first step is we will be getting a file metadata when the file is uploaded, and we need to check it with our table inside S3 object, S3 file data table. So from here we will be storing that inside response S3 client head object bucket and the key file last modified response last modified. It will get the last modified date time from Amazon when the file is last modified. Then the file last modified dot replace tzen info none. This is because on Amazon tzen info it also stores the time zone information, so we don't need that. Like if I'm working in GMT plus 5 and on Amazon we are on GMT plus 4, it will store here, and we always will go into like it will not match in any way. then it will print the file last modified. Then we will be creating a connection and getting a result from our S3 file data table. What are the value for the file last modified in that table, which we already have. And if the result and result 0, the latest one, because we will be descending limit in each type, each time it will be inserted, a new will be inserted, new line will be inserted. So we need the top one is the file last modified. If it's greater than or equal to file last modified, then it will print no new data to load, and then it will insert a file last modified value from the Amazon into our table. Otherwise, it will go and it will download the file from our S3 bucket, CSV content, all the CSV content, and we will be decoding it using more general format, ISO 859-1. UTF-8 does not work in this case. I have checked with this data. I'm just explaining a bit, not all, so you will get all the steps how we are moving. Otherwise, the logic which is provided to you is fine to write your own code. uh, if not, you can work with this code also. So we will be reading the CSV, and from the string IO CSV content, it's always here stored inside our variable. Headers will be none, and we will be giving the names to our columns. Then we are changing the tweet ID from this data frame to string type. Then we will be filter out existing tweets ID. So from our tweets table, we will be filtering out the downloading data frame DF with our existing tweets, and we are only inserting which are not present. So new data DF, then just focus on this part for now. I will explain what's this symbol is. It's checking from tweet ID column as type string is in existing tweet IDs. So if on the data frame and on our SQL table, we are checking what tweet IDs exist, and then we are using a boolean operator. This is a not operator, and it will get a data frame which is not, it will create a new data frame with the variable new data which is not already present in our SQL table. Then we will be defining a chunk size, and then we will be loading that data onto our SQL table. In the end, it will end. In the end, it will insert the file last modified value from our Amazon, whatever the value we get from our Amazon server. So this is for the extraction. uh, I think let's create a new, and this time dag v1, we will name it .py. Let's define the dags, variables for dag. Let me copy this as a whole. I will explain it to you. So our first part is complete. Here what we need to do, here we, and the previously file name is etlv2 when I was testing. Let me change this to etl, because now our file name is etl.py, and these two files should be in the same folder. And we are importing these function transform, check and extract data, and then load data. These functions we are importing from our etl.py file, in which our extract, transform, and load functions situated. So to start the Airflow, we need to define default arguments. Here you can define the owner, depends on start date, whatever you can write it. You can write it 2024 also. Then email on failure. If the pipeline fails, we need an email. If we set it to true, we need to define some values also. Then email on retries one, and what will be the delay within retries. And these are what we need to import. From date time, import time delta and date time. From airflow package, import DAG. Airflow operator.python, import Python operator. We will be executing a Python operator to run these logics: extract, transform, and load. Then we will be defining our DAG. These are general methods. They will be defined. All airflow DAGs will be defined always like that. So DAG, and then we will name our DAG. Let's say airflow DAG Amazon. We will name it. Default arguments, default args, which we have defined on the top. Then description, our DAG schedule interval none, or otherwise if it runs each day, we can remove this none and change it with the time delta days one. Then here extraction Python operator. This is our first task of extraction with the name extraction. Using Python operator, task ID, we can name it as it is or whatever we want. Python callable check and extract data. This we are getting from here. This is our function, check and extract data from Amazon. And in which tag we need to define it, or we need to send that task. This will be in our, here we have only one tag, so it will be one tag, first tag. So the code and everything I will provide. Not writing the code, I'm again saying, because in that way it will become very lengthy. So now we will be copying our transformation logic, and I will explain a bit about that also. So now we have copied our transformation, we have created our transform function, and here also we are creating an engine, because here what we need to do, we need to let me get, in that way you will understand better. So here in the first step, what we did, we have get the data, use the Python inside our extraction function, and put the data onto our raw tweet data table, right? And this is the logic of the function, how it's working. Now we are moving on to transform. Here we will get our raw tweet data from our SQL table in Postgres inside Airflow, and use the Python to done some transformation, and then upload that data into desired tweet SQL table, right? So let's head back to VS Code, and here we have created an engine as before. We are reading the SQL select star from tweets, and this is our table name where we have sent our raw data from CSV file to this table. If df is empty, if data frame is empty, no data in the tweets table, and then return. Assign headers. Here we will assign the headers to our columns: id, tweet id, sentiment, data, query, user, text, and created at. This is inside. Let me open a CSV, and you see here we don't have any headers. Okay, so it's simple file with 1.6 million tweets, and the columns which I have given the name is I got from Kaggle, because there we have a description. Then months to their numeric value mapping. So we need to do the mapping, because here if we see inside our data, here we have Monday April 6, then the time, then PDT 2009. So this is not very useful for us. So this is simple. I have created a dictionary with each month with their respective number. So we will extract the components from our uh, string of date time Monday April. This string we will extract from for the month, from date string from 4 to 7 dot map month map. So we will map whatever the value is, we will map it using month map dictionary. Then for the day, from the date from 8 to 10 character is our day. This one is our day. Then for year, string -4 in the end, whatever the last value, 4 values are from the left. These are the values. So then we will be combining all the month, day and year. The We will be writing a new column inside our data frame with the name formatted data. Then we are dropping some columns, df.drop columns, and then the names of the columns, whatever they are. Then we will be filtered df. We are creating a new data frame using our previous data frame, which we have transformed a bit, and we are using the user Katy Perry and Pretiabili, whatever the name is, doesn't matter. You can write your own name from here. Inside CSV, you can select my bridge or anything else, whatever the requires are. Then we will be creating a connection for our Postgres. Then we will be creating a table. If it does not exist, the required tweets table. And here we have tweet ID, user, and text, and a formatted date. That's it. Then we will get the existing tweet IDs. If there is table already, this pipeline ran and some data is being inserted, let's say after a day, when we schedule our pipeline, we don't change these usernames, so they are already present inside our SQL table. So it will check whether they are present in our mm, uh, filtered data frame and existing tweet IDs inside our SQL table, required tweets table. If it's present, it will not insert that. And this is the same function which we have used before also in the extraction phase. Then we will define the chunks and load the data inside our table. So this is done with we are done with the transform function. And here we will define our second task, which is a transformation task, which is our transformation task using Python operator. Task ID is transform, Python callable, and which function we need to call. This is, we need to call transform function from our etl.py file and provide context to dag is dag. And it's also a task 2 inside our same dag. Let's head back to our third and last step, which is inserting or loading the data inside our bucket on Amazon S3. let me go back to my etl.py file and copy this function. So here, this is the load data function, the last task inside Airflow we are getting. So what we need to do, we need to get the required desired tweets from our SQL table, use some Python to automatically load the data onto S3 bucket. So this is the transformation logic of this function. I already explained that. We have created the engine. We have defined the S3 bucket, S3 object key, and here we are using an F string, a new folder of output, required tweets, name of the file, date and time, and then how we need to define the string, year, month, date, or minute, second, and then CSV. This will be a dynamic. Each time it will run, it will upload a new file. So AW access ID, access secret access key, I will revoke them. You need to define these according to your Amazon S3 account, and also you need to change your bucket name accordingly. With dbengine.connect as connection, then we are again connecting. We are get reading from SQL and defining a data frame. So from our required tweets table, we have put that inside our data frame. If df is empty, no data found in required tweets table, and it will return the function or exit from the function. Convert to csv string.io. This is the function. This is the function for the csv file. So I'm not sure what it's doing, but anyway, df.toCSV, we will be writing the data from to CSV, and index is false. csv.seek 0. This is convert to a CSV. We are converting a data frame to CSV. Then upload CSV to S3 using Boto3 library, and here the service is S3, AWS access key, AWS secret access key, and the variables we already defined. Then try to put the object inside our bucket key and body csv.getValue, and print if the data is successful inside the bucket, accept exception as E, and upload error uploading to data, then whatever the error is. So this is done with the load function. We are done with the load function. So here what we need to do, we will be defining a third task inside our DAG, which is Python operator, and task ID is, you can define whatever pleases you. Python callable is load data function, which is load data function, and provide context to then the dag is dag, same inside the same dag. Then in the end, this is a DAG which will be inside our Airflow. Here we are, this is the logic, our whole logic, and these are the Airflow, you can say a main Airflow file from where it will read a Airflow DAG for us inside Airflow. Then extraction, transformation, and loading. First we need to do the extraction, then we need to do the transformation, and then in the end loading. So we are done with our coding. We haven't done it in a real time because to save time, I will provide all these files to you, and you can read through files and understand the code. This is a bit, you can say, intermediate level code, not too advanced, so it will be easy for you to understand, to get started, or you can simply copy paste this code and change some variables what are required and work with your Airflow project data pipeline. So let's head back to our Chrome, and here let's say if we have our Airflow, and yes, we have our Airflow running because we have started Docker Compose upd, and all the services of for our Docker inside Airflow is being running. So our username is Airflow, our password is also Airflow. So what happened? Okay, I have given a wrong password. So inside our DAG, if you see, I have defined the schedule interval none, so it will be manual. Otherwise, you can define it. Let's run this DAG. Open the DAG, unpause the DAG, and click on trigger the DAG. Once you trigger the DAG, let me go into the graph, and here you will see that this first step is being running, and on the top it will define if it's running, it's in green, and or whatever the color of this box is, this is our direct acyclic graph. First step is extract, and after that step transformation, then in the end the loading. So I'm gonna pause the video here because it's gonna take some time. Let me show you the size of the file. It is a bit large. It's around 230 MB. So first it will load, it will download, and depending on your internet connection how fast it is, it will take some time. So let me pause the video here, and I will be back once it's done. So our first part is success, and if we click on the first part and go into the logs, and it will you see it has inserted 1.6 million new tweets successfully. Now the second part is also a success. Let's go into the logs, and it has inserted 11 new rows into the required tweets. And if we go into the load and this one, it is uploaded successfully with this timestamp. So let's verify it. Go inside our Airflow, refresh. Here we have a new folder created with the name output, and we should have our one file. Let me download that file and open it quickly. So here all our data is being inserted here. You see only one tweet from Katy Perry and 10 tweets from our other user, which is Patty Billy, and a date is also being inserted in a formatted format. Before it was different, something like PDD. Before it was like that, Monday, April 6, time PDD 2009. So this is done with the very small and basic project of Airflow inside Docker, and with the data engineering pipeline of 1.6 million tweets. That's all for this video. Thank you very much. Hope you understand. I will see you soon with a new project, and if you have any recommendations, feel free to contact and define me and send me a comments how we can improve it, what is the other functionality we can include. Please like, share and subscribe. Thank you very much. In the end, please stop your Docker container to free up your computer resources, and for that please use Docker compose down and hit enter, and here it will stop our container. We can double check with our Docker also, and let's say if any container is running, nothing is running, so we are good to go. Thank you very much. Bye bye.